Imagine being trapped in a dry, parched world. The sun blazes overhead, the ground cracks beneath your feet, and there's no water in sight. What would happen to you? You'd likely dehydrate and perish. But there's one tiny creature that can withstand these harsh conditions: snails. These remarkable creatures have evolved an extraordinary ability to survive extreme dehydration, sometimes for years, with minimal water. In this video, we'll explore the science and biology behind how snails survive such harsh conditions. When snails face dry environments, they don't simply die, they enter a state called aestivation. This is similar to hibernation in some animals, but instead of surviving cold temperatures, snails use this process to survive heat and drought. The process begins when the snail senses the environment becoming too dry. In response, it retreats into its shell and secretes a thick layer of mucus that hardens to form a protective seal known as the epiphyseal. This waterproof barrier is key to the snail's survival, as it prevents moisture from evaporating out of the snail's body and seals the opening of the shell tightly, blocking out the external environment. The epiphyseal is not just any basic mucus, it is a highly specialized, protein-rich substance that acts like nature's own waterproofing system. The mucus proteins form a semi-permeable membrane that protects the snail from dehydration while still allowing for minimal gas exchange. This substance has the unique ability to absorb moisture from the environment, keeping the snail hydrated for extended periods. The snail's body is sealed off from the outside world, but the internal environment remains safe, retaining just enough moisture to maintain basic bodily functions. Inside the snail's body, an incredible process occurs as well. When a snail enters aestivation, its metabolic rate drastically drops by up to 90%. This is a form of metabolic depression, where the snail's biological systems slow down to a crawl. The digestive system essentially shuts down, the heart rate slows, and the organs become dormant. This dramatic slowdown allows the snail to conserve energy and water, which is crucial for survival. In fact, the snail can survive without food or water for months or even years by relying on the energy stored in its body. The snail's excretory and digestive systems become nearly inactive during aestivation. Instead of excreting waste, the snail reabsorbs the products back into its body. This reduces the loss of valuable water, helping the snail conserve the resources it has left. With its metabolism in a suspended state, the snail can continue living without the need to eat or drink. In this dormant state, the snail exists in a kind of biological stasis, suspended between life and death, but always capable of awakening once conditions improve. When the environment becomes more favorable, whether through rainfall or increased humidity, the snail can emerge from its dormant state. The epiphyseal softens, allowing the snail to slowly break free from its sealed shell. It rehydrates, absorbing water from the surrounding environment, and gradually reactivates its metabolic processes. Within hours or days, the snail is fully rehydrated and it resumes its normal life, as though no time had passed at all. This remarkable ability to go dormant and rehydrate is key to the snail's survival in environments where water is scarce. Some species of snails are particularly well known for their ability to survive extreme dehydration for long periods. For instance, the Anguispero alternator, a species found in North America, has been known to survive desiccation for over 2 years. One particularly intriguing case involved snails discovered in Australian caves, where researchers found species that had endured complete dryness for up to 5 years. After being rehydrated, these snails emerged from their shells and resumed normal activity, demonstrating the extraordinary resilience of these creatures. This ability to endure extreme conditions for such a long time is not just a fluke of nature, it's a finely tuned survival strategy. The slow, energy-efficient metabolism, combined with the protective barrier formed by the epiphragm, allows snails to outlast even the harshest environmental conditions. While most animals would perish under such stress, snails have evolved to cope with droughts that could last years. This incredible adaptation shows us just how resourceful life can be when faced with adversity. But why does understanding this snail survival mechanism matter for us? The world is facing increasingly erratic weather patterns, with droughts becoming more frequent and intense due to climate change. Studying how snails survive extreme dehydration could offer valuable insights into how other organisms, potentially even humans, might adapt to changing environmental conditions. The snail's strategy of drastically slowing its metabolism and reabsorbing water could inspire new technologies aimed at conserving resources and ensuring survival in extreme climates. It may even have implications for fields like medicine, where understanding how to protect cells from dehydration could improve medical treatment or preservation techniques. In the broader context of biodiversity and conservation, understanding how species like snails adapt to droughts can help scientists predict how other organisms might evolve in response to changing climates. As many ecosystems face the threat of desertification and water scarcity, the resilience of snails offers a hopeful glimpse into nature's ability to adapt and survive. Their ability to wait out the worst of the drought and emerge when conditions improve provides a model for how life on Earth might survive the challenges of an unpredictable climate. From the creation of the epiphragm to the dramatic slowing of metabolism, snails are an amazing example of nature's ingenuity. They remind us that survival often isn't about battling the elements head-on, but rather about adapting to them and knowing when to retreat and conserve resources. As our world faces more extreme weather events, perhaps we can learn a thing or two from these tiny, resilient creatures. The science of snail survival is a reminder that sometimes, to thrive, we must slow down, conserve, and wait for the right moment to re-emerge. If you enjoyed this deep dive into the fascinating biology of snails and their remarkable survival strategies, be sure to like, subscribe, and hit the bell for more insights into the wonders of the natural world.